So none of you remember, it seems. Anyway, let me start in that case. So we are talking about quantity of storm water and then factors affecting the quantity of storm water. Up to here, I guess I discussed in the last class. So we'll just proceed further and we'll try to, remember what we discussed in the last class. So the major aspect of this, the entire stormwater quantity is basically the measurement of rainfall. So it starts from there. So the rainfall intensity could be measured by using rain gauges and recording the amount of rain falling in unit time. So the rainfall intensity is usually expressed in millimeter per hour or centimeter per hour. I guess the standard uh, device. If you refer to any textbook, you will be able to see it. In addition, if you go through engineering hydrology books, in the first chapter we discussed in detail about how to measure the rainfall. Now the rain gauges used can be manually recording type or automatic recording rain gauges are also available these days. So, as far as stormwater measurement is concerned, or estimation of stormwater is concerned, usually we go ahead with two different formulas. One is rational method, another one is empirical formula method. So these are the two methods which are adopted commonly, and in both the above methods, the quantity of stormwater is considered as a function of intensity of rainfall, coefficient of runoff, and area of catchment. So, uh, what is stormwater? So basically, it's a after effect of the rainfall. Fine. So once the rainfall is happening and the entire catchment area and the coefficient of runoff, because the entire precipitation which is coming on the surface will not be accumulated as the storm water. So some amount of rainwater will percolate through the soil, and that part should not be taken when you calculate the quantity of storm water, which is why we take a coefficient of runoff which is usually less than 1, and that is the way we actually leave a fraction as percolated water. Apart from that, we have the area of catchment. That is what is also required to remember while estimating the overall quantity of stormwater for a particular area. Now the very important parameter one should keep in mind is time of concentration. So this time of concentration is a very tricky term which we would like to discuss over here. And this time of concentration, what is this time of concentration? So the period after which the entire catchment area will start contributing to the runoff is called as the time of concentration. So just try to remember, the period after which the entire catchment area will start contributing to the runoff is called as time of concentration. So time of concentration is different than the starting time of the rainfall. So there is a significant time lag between the time of concentration you start counting and when your rainfall has started happening. So this is very important to remember, that there is a difference, and that actually depends upon several other factors, mostly the surface characteristics of that particular catchment area. Fine. So what are the different aspect of this time of concentration we are going to discuss now? So the rainfall with duration lesser than the time of concentration will not produce maximum discharge. So this is quite understandable, that if you have a shorter period of rainfall, so that will not produce the maximum discharge, because before reaching to time of concentration only this precipitation would stop. Next is, the runoff may not be maximum even when the duration of the rain is more than the time of the concentration. Why? because in such cases the intensity of rain reduces with the increase in its duration. So this is another one important practical factor which needs to be considered. If you see or if you observe the intensity of rainfall, and it will reduce with increase in the duration, and this is very very practical aspect. Even if you observe, you will see the same thing. Next is the runoff will be maximum when the duration of rainfall is equal to the time of concentration, and that is called as critical rainfall duration. Fine. So again, I will be mentioning this. So the runoff will be maximum. So we'll be dealing with maximum runoff since we are finally going to talk about the design of the sewers. So am I audible? Hello? Are you able to hear me?
Yes, sir.
Okay. Because respond, otherwise I am unable to see whether I am online or not. So whenever I ask you, people just just response, so that I can understand if people are able to hear what I'm telling. So once you have a critical rainfall duration, then the chance of getting maximum runoff would be high. Fine. So the time of concentration is equal to the sum of inlet time and the time of travel. Fine. Remember this. Time of concentration is the inlet time plus the time of travel. So this is, so now we should be talking about, in that case, what is inlet time. So this is the way, step by step, we actually calculate the overall quantity of sewage, or we say storm water. The sewage is not a correct word for the waste storm water. So what is inlet time? Because we have discussed about time of concentration, we have discussed about critical rainfall time, but then now we need to talk about the inlet time, and try to remember whatever terms I am trying to discuss over here. Just try to remember them and try to understand the difference with other relevant terms which we'll be discussing here. So what is inlet time? So inlet time is essentially the time required for the rain in falling on the most remote point of the tributary area to the flow across the ground surface along the natural drains or gutters up to inlet of sewer is called the inlet time. That means if you go back to the previous figure, and if you try to see this particular, just one second, yeah, if you try to see this particular figure over here, run up from a given catchment, you'll be able to understand. So here TI stands for inlet time. Fine. So this is basically the time required for the rain in falling in the most remote area. So let us consider this point, this point, this point, and this is the inlet sphere. So the time taken once the precipitation is happening at this point, so the water from here coming to here, the time it takes is basically known as inlet time, which is denoted as Ti, T prefix I. So the inlet time we can express, and it can be calculated by the help of the equation which has been given over here. You can see that it has relation with the length of overland flow in kilometer from the critical point to the mouth of drain. So that is the linear length which we are talking about, from this point to this point, from this point to that point, from this point to that point. So you can take for each one, you will have a different L, and you can take like one particular L for a one particular point. So length of overland flow in kilometer from critical point to mouth of the drain, and H is the total fall of level from the critical point to the mouth of drain in meter. So these two are very important, because see, H would actually dictate the gradation in the ground surface, and if it is more, then the time will be taken less. So that is why L and H both are important. So we calculate how Ti equals to 0.885 L cube by H whole to the power 0.385. Now here Ti is denoted as time of inlet, I have mentioned before. Now the next important aspect is time of travel, because we have discussed time of concentration. I'll go back here again, and if you try to see, we have discussed inlet time and time of travel. So now let us consider time of travel one. What is that? So time of travel is basically the time required by the water to flow in the drain channel from the mouth to the point under consideration, or the point of concentration is called as the time of travel. So length of the drain by velocity within the drain. So if we consider B is the exit point, so the time taken within the sphere for the water to come from A to B is basically the time of travel. So once we talk about the time of concentration, we say that it's a summation of inlet time, that is Ti plus the Tt. So this is the way we calculate separately, Ti, we calculate separately Tl, Tt, and then finally we get the value of time of concentration. Fine. Another one important aspect is runoff coefficient. So runoff coefficient has to be, I have told that whatever precipitation is happening, the entire water cannot be considered as your surface runoff. So that is why we take a runoff coefficient, and which is basically that depends upon several factors which I'll be discussing. Now the runoff coefficient can be defined as a fraction which is multiplied with the quantity of total rainfall, which is what you are measuring through the rain gauge, to determine the quantity of rainwater which will reach to the sewers. So this is very important. The quantity of rainwater which is coming on the ground surface is not equal to the quantity of rainwater which is reaching to the sewers. So there is a difference, and to calculate the difference, or we basically consider this runoff coefficient. So the runoff coefficient depends upon the porosity of the soil cover, wetness, and ground cover. And these are the three things. And the overall runoff coefficient for the catchment area can be determined by the help of the formula which I have given in the top line in this particular slide. So you can go through that formula. C is equal to A1 C1 plus A2 C2 plus AN CN by A1 plus A2. So the area, the summation of the entire area, where A1, A2, AN are the types of area with C1, C2, C3, and Cn are the coefficient of runoff correspondingly. So C1 is the coefficient for the area A1, C2 is the runoff coefficient for the area C2. So once you want to calculate for the entire area A, so let us again consider this particular figure. Suppose this entire area is A, fine, and you have small area which has been divided based on those three factors which I mentioned, fine, ground cover, soil cover, and wetness. If it is similar for a particular area, so consider that as one area A1, and then depending upon the type of those three parameters, you get the value of C1 from the standard table given by the codal provision, and then you calculate the A1 C1 for that particular area. Likewise, you do for the entire whole area, and the A, that is basically again the summation of the small area A1, A2, A3, and AN. Once you get that, it is easy for you to calculate the overall runoff coefficient C. Fine. Let us come back to this particular slide, and the typical runoff coefficient for different ground cover is given in this particular table. So directly you can take, I have just taken it from one textbook. So you can take this for business area, it is taken as 0.7 to 0.9, apartment area is 0.5 to 0.7, single family area 0.3 to 0.5, parks, playground, lawns, it is paved streets, it is higher, because the chance of percolation is less. Now try to understand, why we are taking higher and why we are taking lower. That is very important. Religiously following table is one thing, just to solve problems. So that you do, I have no problem. But then try to understand why coefficient of runoff is varying and on what basis. And you can use your general sense to understand, when you have watertight roofs and when you have paved streets, so the chance of percolation is very less, and that is the reason the coefficient is taken higher. So the loss is lesser in this case. So hope all of you have understood this. I'll go to the next part. So that is the rational method to calculate the stormwater. So through this method, stormwater can be, if you see here, sometimes back we have told that we have rational method and empirical formula. So now we'll be discussing about rational method. here, and through rational method, how can we calculate the by estimate by formula q equals to cia by 360, we can directly calculate the quantity of stormwater by rational method, where q is the quantity of stormwater in meter cube per second, and you have coefficient of runoff c. Now how you will calculate the c, that I have already discussed in the previous slides. I is the intensity of rainfall, again you know how to calculate that, and A is the drainage area in hectares. So this is the way we can calculate the and or if we write CIA by 360 is okay, or if you can write the same formula as 0.278 CIA. And you have to think, you have to keep in your mind one thing very clear, that you cannot change the unit. So what you do is you first convert the unit in the mentioned one or recommended one, and then you calculate the stormwater quantity by using the rational method. So key q has to be in meter cube per second, I has to be in millimeter per hour, and a is in square kilometer. So if you don't convert, then the calculation will be a mistake. I guess these kind of challenges you would not face while answering in semester, because all of you are actually writing the same question papers, and those who cannot differentiate these things, they'll simply tally their answer, and then they can rectify their problem. I have no problem in that, but the problem is when you go for competitive exam, that cannot be done. You cannot tally your answer with your friends, and in that time you will do mistakes. So that is why I try to remember these small details, which are actually very important to remember. All these unit should be remembered before utilizing the rational method for calculation of quantity of stormwater. Fine. Now goes to empirical formula. As I have already mentioned that we have two different methods. Empirical formula are used to determine the runoff for very large area, and various empirical relationships are developed based on the past observations on specific site conditions, suiting a particular region. So these empirical formula can be used for prediction of the stormwater runoff for that particular catchment. So the main limitation with empirical formula is they are sometimes it is valid for a particular area, sometimes it is valid for a particular time. So once you fix that particular area, or once you know that this particular formula can be utilized in that area, then there is no problem. It will give you very good results. And likewise, we have here three different formula which we are going to discuss. So one is Berkeley-Ziegler formula. So you can see in the left hand side I have written. Then we have McMath formula, that is predominantly used in United States, and we have Fuller's formula. So that also has been shown over here. So here one term is new to all of you, that is S. So S is the slope of that area in meter per 1000 meter. M is another one, that is the drainage area in square kilometer, and A is known to all of you. So I'm not going to talk about N. But again, what you need to see, you are talking about empirical formula, so unit are fixed. You cannot do the same thing with different units, so then you will get erroneous results. So that is why you always have to remember about the unit. S is always presented in meter per 1000 meter. M is always in square kilometer, and A, as you know, it is in hectare in these three cases. However, in the previous case, we discussed that in rational formula, our A was in square kilometer. So these things has to be kept in the mind. Another one very important formula, that is Quichling's formula. This is the formula which we'll be using for most of the time. Fine. So as per Quichling's formula, QP equals to 1 by 36 K into PC into A. Try to see all the different connotations which we are going to use here. K, coefficient of runoff. All of you know how to calculate, how to obtain that. A is the catchment area contributing to the runoff at the considered point in hectares. So that is also okay. Now PC is the critical rainfall intensity. Now we have already discussed about this critical rainfall intensity of the design frequency. That means the rainfall intensity during the critical rainfall duration equal to the time of concentration in centimeter per hour. So this we need to calculate, right? So in the absence of standard intensity duration curves, the value of PC can be obtained by employing the formula given over here. So we have two different methods to calculate PC. Once we don't have, see, unless and until you have standard intensity versus duration curves, you cannot get the rainfall intensity during the critical rainfall duration. So once you don't get that, it is very difficult to calculate the PC. And to overcome that issue, what is done is we have two different standard methods. One is the 1 hour rainfall. So the value of 1 hour rainfall of a given frequency at a given place can be found, and then from the charts we can get the desired value. So this value of 1 hour rainfall is multiplied by the area distribution factor so as to obtain the P0. Now the value of P0 is further multiplied by a factor, that is 2 by 1 plus TC, so to obtain the PC. Fine. So PC is equal to P0 into 2 by 1 plus TC, but TC is the time of concentration in hours. All of you know that. Fine. Now let us go to the next second part. So that is the since the intensity of the rainfall is inversely proportional to the duration of the rain, and intensity duration curve can be represented by a generalized equation of the. So now what you are doing, we are trying to see the entire behavior in generalized form. So that is P equals to A by T plus B, where P is the rainfall intensity, T is the time in minutes, and A and B are the constants. And the values of A and B can be obtained from the standards given by any standardizing authority. In this case, you can see that the value was given by Health Ministry of Britain as 75 and 10 respectively, T varying between 5 to 20 minutes. Fine. And that is 120 respectively for T varying between 20 to 100 minutes respectively. So T actually is you need to understand very well, and once you get that value, then the entire equation becomes P equals to 75 by T plus 10 or P equals to 100 by T plus 20. Now using TC in minutes in place of T, the equation in the equation 3.7 and 3.8 which I have written over here, the values of P and PC can be evaluated. Now once you get the value of P and PC, then what you can do is you can utilize them. Apart from that, the above generalized equation which we discussed, certain other empirical equations also can be used for determining the rainfall intensity. So for localities where rainfall is very frequent, directly we can use this formula. I have given over here. The formula is applicable for places where heavy and frequent rainfall occurs, gives an intensity for 5 years frequency. So depending upon what kind of rainfall characteristics you have to choose which one would be the most suitable. Now for rains having frequency of 10 years, the equation which is suggested is 38 by root T. Now these nomenclatures T we have already mentioned before, and for rains having frequency of 1 year, then the equation again changed, you can see here. And then finally we have the Kuchling's formula for storms having 10 years and as well as storms having 15 years. So we can understand these equations, whatever we have shown over here. Now that can be used finding the value of TC. But then you have to remember that they all are empirical equations. They are not very reliable if one of the parameter gets changed. So therefore, generally, while designing the stormwater drains in modern days, we tend to avoid such kind of equation to be used. However, you have to go by this formula till now. If you don't have any rainfall records, past records for a certain area, so you have no other options apart from choosing this particular formula and then getting the PC value and finally you calculate the overall intensity. So you have to do it unless and until you have uh, proper rainfall records available where you are planning to design the sphere. So here you can see that estimate on a peak runoff. So we have given hourly maximum rainfall in centimeters having 2 years frequency in India and neighboring countries. So these contours are actually measured, how much is the rainfall hourly maximum, and in right hand side we have hourly maximum for 5 years frequency. Fine. So this I have given just to have an understanding how this frequency, for how this intensity gets changed with respect to frequency. So this is another one. Here we have actually taken frequency as 50 years. So we can again see a change in this case, and you can take this 3 figure and you can just I just took it from one standard textbook. So if it is available, you can check these 3 minutely, try to understand the difference and what is how the intensity is changing with respect to frequency. So we have one problem over here. You can do this problem. It will be easier for you to understand what we discussed sometimes back and how to calculate the runoff. So can you please do this problem and let me know the answers? Just yeah. So now let me go back to the screen and yeah. So what I want is I want answer from all of you. Problem has been given. I'll just keep the problem for some time more so that you can see and you can. Is that okay? All of you write the problem and solve it and then tell me the answers over here itself. This is the problem where you can utilize the what we discussed, how to calculate the coefficient of runoff. And once you get that, finally by employing Quichling's formula, you can calculate the QP. That is the maximum rainfall intensity which we need, right? First, obtain the value of K. So K equals to K1 A1 plus K2 A2 plus K3 A3 plus K4 A4 by summation A, means total area. All of you have written the problem? All of you have written the problem? Could you write the problem? Or should I show for some more time? Why don't you answer? Am I audible? Hello? Am I audible?
Yes, sir, audible.
Why can't you speak? Why are you typing here? How many times I have to ask you people? Then don't do class if you are not interested. I'll save my time. If you don't interact, being in 5th semester or 6th semester, then there is no point. What we are going to tell in your juniors? It's a basic courtesy that I am asking you something, you will be answering it. After 2 years, when you will be placed somewhere, and if you don't answer properly to your higher authority, they'll simply throw you out from the company. You know that? So always try to maintain a professional ambience. Though you are through online, but this is not the right way. I'll just see for few more times, and if you people don't respond, I'll do not take your class. Let me see who is going to take. All CRs are sleeping, it seems.